Hi guys, in this video we are going to show you a game that we have designed called Path Quest. As you can see, this is the welcome page of our game. You can start a new game, view the instructions or simply quit. First, let's view the instructions. Move the man to the gold coins, make it as early as possible. The A-star algorithm which we are using is used to provide the shortest path to every gold coin. We click on the back button and we come back to the home page. Now we are using this game to explain the A-star algorithm. In this game we have a game scenario in which we have coins distributed randomly and there is a clubhouse which is the final destination, and there are obstacles all around the scenario. The obstacles include trees, pond and wooden blocks. We have to collect coins and reach the final destination in the shortest possible time. There will be a timer to record the time taken by the player, and at any point the player can view the shortest path from his current position to his next point of interest. From this purpose, we are using the A-star algorithm to dynamically calculate the shortest distance from the current position to the position of interest. It is the process of plotting an efficiently traversable path between points. Now see, I move my player to this position and look at the path traversed, which was calculated using the A-star algorithm by dynamically passing the player's old position and the next position of interest, and also considering all the obstacles. The first thing you should notice is that we have decided our search area into a square grid. Simplifying the search area, as we have done here, is the first step in path finding. This particular method reduces our search area to a simple two-dimensional array. Each item in the array represents one of the squares on the grid, and its status is recorded as walkable or unwalkable. The path is found by figuring out which squares we should take to get from source to intermediate destination. Once the path is found, our person moves from the center of one square to the center of the next until the target clubhouse is reached. Once we have simplified our search area into a manageable number of squares, the next step is to conduct a search to find the shortest path. Now we begin at the starting point and add to it an open list of squares to be considered. Right now there is just one item on the list, but we will have more later. It contains squares that might fall along the path you want to take but maybe not. Basically, this is a list of squares that need to be checked out. Look at all the reachable or walkable squares adjacent to the starting point, ignoring squares with walls, water or other illegal terrain. Add them to the open list too. For each of these squares, save the current position as its parent square. The parent square is important for tracing this path. The current square position is now dropped from the open list and added to a closed list of squares that we don't need to look at again. Now we choose one of the adjacent square on the basis of a cost which is given by f is equal to g plus h. The lowest cost is chosen. G, the movement cost to move from the starting point to the given square on the grid. H, the estimated movement cost to move from that given square on the grid to the final destination which is given. We assign a cost to each horizontal or vertical square move and a cost that is 1.414 times of horizontal cost to the diagonal cost. H can be estimated in a variety of ways. We calculate the total number of squares moved horizontally and vertically to reach the target square from the current square, ignoring diagonal movement and ignoring any obstacles that may be in the way, and multiply them by the cost of horizontal movement. And the one with lowest cost is selected and the player moves to that square, and the same process is then repeated for that square. Now let's play this game in order to make you understand how the A-star algorithm actually works. Now since gold coins remaining as 0, he can go to the clubhouse. Now let's play this game. Here you can see the elapsed time has started going on. It's 2 seconds, 3 seconds. We have to collect these coins in order to reach the final destination, which is clubhouse. The obstacles do not allow us to pass through them, and the route which the person is following is represented after every step, and that route is discovered by the A star algorithm. Now the gold coins remaining are 0, so he can go to the clubhouse. So we can quit this game in order to end this. Thank you.